Okay, in this video, we are going to solve this problem right here. So we want to find the derivative of 5x divided by x cubed plus 2. And this is a prime example of a quotient rule problem where you have low d high minus high d low divided by the square root of what's below. And let's see this in action. And so we're going to say equal low, meaning denominator, x cubed plus 2, d high, derivative of the numerator, so 5x, minus high, numerator, d low, derivative of the denominator, divided by the square root of what's below. Now, we can kind of clean this up a little bit, so we'll keep our x cubed plus 2, and then we'll take the derivative of 5x, and the derivative of 5x is just 5, minus parentheses 5x, and the derivative of x cubed plus 2. The derivative of x cubed would be 3x squared. You bring down the 3, you take 1 less, so 3 minus 1 is 2. And the derivative of positive 2 is just 0. And then divided by the square root of what's below, so x cubed plus 2 squared. Our next step, we can kind of expand this, so we have 5 times this stuff, so 5x cubed, and 5 times 2 is 10, so plus 10. And then minus 5x times 3x squared, we would get minus 15x cubed, because 5 times 3 is 15. You have a negative in the front, and x times x squared is x cubed. Divided by this piece, which is x cubed plus 2 squared. And now we can group like terms, so 5x cubed minus 10x cubed, we would get negative 10x cubed plus 10, divided by parentheses x cubed plus 2, close parentheses, squared. And one minor thing we could do is we could take out a negative 10 because 10 is on both of these pieces and the leading coefficient has a negative. So if you want to clean it up a little bit, you could say negative 10 parentheses x cubed, because negative 10 times x cubed is negative 10x cubed, minus 1 because negative 10 times negative 1 is positive 10, divided by our denominator, which is x cubed plus 2 squared. And this right here is our final answer. And that's all we need to do for this problem. Also, check out the description box for more practice with derivatives. And that's pretty much it for this video.